Using trigonometry, express tan x as sin x by cos x and cot x as cos x by sin x. Root tan x is root sin x by root cos x, and root cot x becomes root cos x by root sin x. Substitute these values in the integral. On adding the fractions, we get root sin x the whole square plus root cos x the whole square, the whole thing divided by root sin x into root cos x. Root sin x into root cos x can be expressed as root of sin x into cos x. Consider the expression sin x plus cos x in the numerator. The antiderivative of sin x is minus cos x, and the antiderivative of cos x is sin x. So sin x plus cos x can be written as d by dx of minus cos x plus sin x. This is the hint to the substitution. So we take t equal to sin x minus cos x. We have to express sin x into cos x in terms of t. So we square both the sides. We expand the RHS using a minus b the whole square identity. Using trigonometry identity, sin square x plus cos square x becomes 1. So t square equal to 1 minus 2 sin x cos x. Rearranging sin x into cos x equal to 1 minus t square, the whole thing divided by 2. So t equal to sin x minus cos x, taking differentials, dt equal to cos x plus sin x dx. Substitute these values into the integral that we simplified. So the required integral becomes root 2 times integral dt by square root of 1 minus t square, which on integration becomes root 2 sin inverse t plus c. Substitute the value for t.